Hello and welcome to the enclosure. I've been a little bit under the weather for the last, well, it's the March 1st, and I got sick on about the 21st of December. So it's been a bit of a challenge, but I've been pushing through the heat system. I've got basically the system complete other than hooking up the heat pump. Between myself and Benoit from ThermAtlantic, we tried to get a technician to do the pressure test and the final brazing and stuff and charge the system, but they were too busy. They weren't interested. And most of the companies, they work for specific manufacturers, and this is kind of a prototype match between the GREE inverter heat pump and the DX2W-EX1 from ThermAtlantic. So I originally didn't want to spend all the money on the tools, but I realized that I've got a argon tank here that I had from a TIG welder that I've never used. And you can use argon for purging the oxygen out of the lines, just like you can use nitrogen. Argon tends to be a lot more expensive, which is why everybody uses nitrogen. And really all it required was a simple pair of fittings to convert from the welder fitting, the TIG welder fitting, to the standard refrigerant hoses. The problem is it took me 9 stores to find these two fittings and 4.5 hours yesterday. So it was an interesting day, but we got her done, and we're now ready to go. I made some mistakes on this. Originally, I wasn't thinking, and this is all going to be concrete later on. I had the line set coming across and up, and it's then below ground, and that's not good for the line set. I guess you can condense the liquid out of it. I'm not a refrigeration guy, so I'm going to make a mess of how I explain this, but I think you can condense the liquid out of the stream because it's too cold. And when your inside unit is below the heat pump, GREE requires there to be this loop, no drip loop or something that they're calling it. So I had to redo stuff. I had already cut the copper, which meant now I was too short. And then getting this bent up was a little bit of a challenge. And the first one didn't turn out. It kinked too much on me, so I had to do it again. But it looks like it's raining, so let's hurry on this. I used a pipe bender, die and rollers to do all my bends. The flare, this did not come with flares. It was just straight pipes. So you clean it out, you cut it straight, make sure you ream it. Make sure you ream it with it pointing down so all the shavings drop out, and give it a good tap after. And then you use a flare tool. And basically, this is the flare tool I have. You just stick it in up to the point where it hits the stop, put this over, tighten it down, and you just keep on tightening it down until it releases itself, and then you know it's done. It's a good idea to put a little bit of refrigeration oil on the flare first, just to make sure it's nice and smooth, and then you test it after to make sure it fits into the fitting properly. So I've done all of that. The next step to join pipe is that you need to have one side expanded with, I think it's called a swage. And basically I got, there's much more expensive versions, but because I'm doing this one-off, I got this drill version. And what I learned from the web, from experienced people, is that you want to make sure that you keep it spinning high speed all the way in and out. Don't slow it down, and you actually end up with a really nice polished swage. Flared connection, that takes care of that. So now what we're going to be doing is we're going to be running just a tiny bit of argon through the system. You don't want to pressurize it. All you're doing is trying to get rid of the oxygen so it doesn't create oxides inside as you solder. And I'll have a link to a really good YouTube video showing the difference between purging and non-purging. Okay, so let's get busy. Normally you're using either acetylene with a turbo torch, which just takes the air around you, or an oxyacetylene torch. This is fairly small. I did a test and I found I was able to get it cherry red, which is the color you're looking for, with just the MAP gas. This isn't true MAP gas, it's a new formulation, but it still gets hot enough compared to just say propane. Okay, the last part, I guess, I've cleaned off the inside and the outside. And then the last part is that we have a 15% silver rod. And so that's basically it. We're going to turn on our gas, and I'm just going to turn it on so I can barely hear it coming out here. And I'm basically just doing it so that I can hear that I've cut the flow off. Now, normally the pros have flow meters to show exactly how much you're flowing through the system. But because we're not pressurizing and we're just taking out the oxygen, we just need a tiny little flow through it. Okay, that takes care of that. It's all basically connected inside. I've got some brazing to do. I've got 4 connections inside, but they're basically all pipe tight like this. And now we'll go ahead and start. I've got a heat mat here. It'll protect the casing from discoloration and overheating. It can take a straight flame fairly well. I can still hear the argon coming through, so I know I have continuity coming through, and now we'll start. So you're supposed to start with the pipe going into the swage first, and then with the swage itself. Starting to get cherry. Obviously with an oxyacetylene, it's much faster. Okay, I'm not being very successful here, so let me regroup. Okay, so I've regrouped. I've taken some insulation back and put some cold rags on there. Because I'm using a low temp gas, it takes me a lot longer to heat everything up, and therefore it travels up a lot more. The only reason I'm willing to do this is because I'm nowhere near any of my service valves. I'm always mid-pipe when I'm going to be doing my my torching. So we're going to try this again, and hopefully this time it'll be a little bit better. Take 2. Well, I think that is it. That was A lot harder than the test that I did indoors. It is quite cold and windy outside, so that takes quite a bit of the heat away. Maybe the argon itself is taking heat away. But yeah, that took a lot longer. So some of the things that I learned watching some of the pros with their apprentice videos is you want a nice little, basically a crown over the seam so that you can take your fingernail and you can't basically catch it inside the seam. So I've tried to do that. The other thing is you generally don't want to put water directly on the soldered connection. You draw the heat away on each side of it. That's just something that I've learned from some pros just in general on soldering and brazing. Yeah, that's now good. So that is not a pretty joint. I think it's a good joint. I think it will, it'll be airtight and pressure tight, but we'll find out when we do the pressure test. So I'm now going to do the ones inside. I won't take you down for that. It's up in the ceiling and you won't really be able to see it. And I'll come back when I'm ready to do the pressure test. Okay, thanks for watching. Okay, welcome back. I didn't finish the brazing yesterday. I had to haul out my oxyacetylene full-size bottles and torch from storage. One of the 3/4 onto the DX2W, I was not able to get hot enough with the MAP gas. So I finished that off this morning, knocked over my argon tank and busted the regulator and broke off the hose. So I had to replace the hose. The regulator I can use for now because there's a regulator on here. And so what I'm going to do today is I'm going to hopefully do the pressure test. So the first step is going to be to torque up the line set connections, flared connections. I haven't torqued those up yet. I just loosely put them on. So let's get to her. I've got my manifold gauges in hand here. Oh, I guess I put that on a little bit tighter than I thought. Got the blue on the large pipe and the red on the small pipe. So on heat pumps with reversing valves, there is no high pressure, low pressure, because it goes both directions, as far as I understand. Again, I'm not an HVAC guy. So what I have seen on the manufacturer's instructions, they want to see some oil put on the back side of the flare. So I'm going to do that. Just a little bit of pump oil. And then I'm going to use the Nylog Blue gasket thread sealant for the face and the threads. And it's compatible with our 410A. So I'm just going to put a little bit on, finger here, and a little bit on the flare surface. I'm just not getting it totally inside. Sorry for the car alarm in the background. And a little bit on the surface here. So like I said, it's compatible. It'll get any that is on the inside will get absorbed into the refrigerant oil. And that's very annoying. There's a daycare close by here. Okay, that's that. Now I'm going to take a little bit of pump oil, just a tiny bit, and put it on the back side of the flare. And the manufacturer recommends that. I believe it gives, it reduces the friction so that you're getting appropriate torque values. Okay, that's good enough for now. So I'm going to take out my nice handy dandy torque wrench, and I am going to, and I haven't used that for a couple of years, so it's going to take me a while to become familiar. And in order to use, I got this for automotive, so it's not the right motion necessarily for HVAC. So you have to get crow's feet to adapt. And from what I understand, you want it at a 90-degree angle. And so now you have to follow the manufacturer's torque rating. So for 3/4 inch line, 70 to 75. So let's set this to, let's see, that's 75. I'm just going to go a tad below 75. And I'm, of course, going the wrong direction. Where am I? Yeah, I'm going the wrong direction. So, how is that possible? How is that possible? Oh, is it reverse thread, I guess? There we go. Okay, so hopefully this will do it. And I'm not getting a torque on there that I like. I've never used this in a crowfoot configuration before. But that seems way too tight. I'm going to take it way down just so we can see whether or not it ever releases. Yeah. Huh. Interesting. Well, so much for that. Yeah, I don't know. So I'm just going to do it the hack way by hand, unfortunately. Okay. And of course those don't fit. Okay, I'm going to pause you for a sec and come back. So this is what happens when you're not in the business and you don't have the right tools. Shouldn't be complaining, but blaming it on the tools, but the tools often do make the difference. And I didn't want to spend a fortune for what was going to be a fairly limited need. So I'm just going to do what feels right. Okay. Okay, now that that's done, not necessarily correctly, but hopefully without leaks. I don't think I've over tightened it. Let's see what we do next. So the next step is to try to pressurize the system and then use a bubble leak tester. So I've never used these gauges before. Let's see what we end up with. I sort of know what's supposed to be happening, so I'll take you along for the ride. Okay. Now, I'm going to, first of all, I'm going to want to purge. So I'm going to take, let's take the red side off. Open that up. And open up the blue. And I should be able to. Okay, well, we're pressurizing, but what I'm not happy about is, oh, I guess it helps if I do that. There we go. Not thinking straight here. So I'm just trying to get out any oxygen in the system. What I'm worried is that my argon bottle has been sitting for so long that it has just leached out of the metal tank or around the seals. Because this isn't a pressure, I think this is fully open and this is not the pressure I expected. So I'm going to close that. And so at this point, what we want is to have a much higher pressure. Let's see if I can get up there. And then have both gauges the same and let it sit for, I wanted to let it sit kind of overnight and make sure I didn't have any leaks. It's slowly climbing. I might get her. Coming up to 100 psi, which is kind of where I wanted to be for initial test. It's a little bit higher on here. I want to get this one up to 100. Traditionally, I think this is called the high pressure line, or the liquid line, as opposed to the gas line. Okay. Yeah, there's definitely not enough pressure in this thing. So I'm going to have it recharged before I can do my final, potentially, unless I just accept that I'm going to do a pressure test at only 100. I think they typically go much higher. Okay, so that's up. I'm going to bleed out a little bit on this side. Okay, I'll let that sit, and then while that's sitting, I'm going to do some bubble test. So the industry seems to feel that better bubble gas leak detection is the best go-to leak tester. So we'll give her a try. I'm going to first of all test, actually what I'll do is I'm going to turn those off. Now I'm isolating all of this for leaks, and I only have to worry about this. So I think normally in the field, they're going at a higher pressure, and then those that are the real pros have a digital gauge, and that shows any degradation in the pressure much faster than a visual gauge where you're trying to measure between the lines kind of thing. So they typically, I think, are doing 10 to 15 minute tests. Those with gauges, I think it's more like 20 to 30 minutes. But I wanted to do a bit longer, so let's see here. So far it's looking good. I had a lot of practice soldering the 1¼ inch copper piping for the water side of the system, and this is a little bit easier than that. Okay, I'm going to go inside and do a test there. I'll pause you for now. Okay, I've sprayed all the joints. Not seeing any leaks whatsoever. So this, it'd kind of be nice to simulate a leak so you know, even so I know what happens So what I might do is I can do that probably here. Yeah. And I have a little bit of a leak there. And of course I left my goop downstairs. I'll be right back. Okay, so we're gonna simulate a leak on this here and see what happens. So let me take, yeah, right away you start to see it bubble. So let me undo it a little bit. I don't know if you've been able to see, there's a nice big bubble forming. I'll take you in for a closer look at that, if I can. Okay, you should be able to see the bubbles forming there. Oh, there's an actual leak. So now I'm just going to let it sit for a while. I'm going to recheck maybe in half an hour for any leaks. I'm going to see if I can get the pressure up a little bit higher. Even 150 I'd be probably happy doing the test at. And then we'll come back and show you how to, or how I'm going to learn how to evacuate the system of air, put a vacuum on it, and then release the refrigerant charge from the heat pump into the lines. Okay, thanks for watching. Okay, we're back on day 3 of my attempt to pressure test and release the charge on this mini split. As I showed you yesterday, the argon tank that I had that was brand new, but back in 2005, had leached out the majority of its gas and it didn't have enough pressure. So I was only able to get the system up to 100 psi, actually 104 psi. So there's a digital pressure gauge, pressure transducer inside the ThermAtlantic indoor module, the DX2W. And so I was able to monitor it over the last 24 hours, and it went from 104 down to 98. Now, that could indicate a very slow, small leak, or it could be because today and overnight was a much colder day than yesterday. So the pressure goes down as the gas condenses in the colder temperatures. But either way, I wasn't comfortable proceeding. So I was able to rent an argon bottle for basically just the gas price. So it's like 75 bucks and then $1 a day for the bottle rental. So we're going to boost it up to 250. The design pressure is 550 on the high side and 240 on the low side. We're on the high side here. So let's do 240 so we don't max out either side. And we're just going to bring it up here, and then over the next few hours I will look at the readings from the transducer on the computer program and see whether or not we lose any pressure. But at this higher pressure, if there is a leak, we should be able to find it a lot easier with the bubble test. Okay, so I also got my new regulator, just a cheap online one. Let's close this off. Okay, so it's reading, let's see here. It looks like it's about 1,800 pounds, so it should be more than enough. I'm going to release it into the system first. Okay. And I'm just going to bleed off some of that air, so we make sure that we're not introducing air into the system. And I'll do that, I'll do that right here, the closest point to where we're going in. Okay, so we're going to start, that brought that up. And now we can just start. Okay, that should be more than enough. I guess I'll keep it on just a tad while I'm doing it up. All right, that should do her. And I'm gonna close that off, release this, and so yeah, it shows just under 100, and we're gonna take it up to 240. And what's happening here? How come I'm not getting higher pressure? Okay, we're there. Did I not? We're open. Okay, this is interesting. I'm at a loss at what's happening. The Schrader valve is still in here, but these have fittings that are springs that push it down. But why am I not getting a higher pressure in there? So we're going to try something here. We're going to close that off. And I'm not sure what's going on actually. Sure, all you HVAC guys out there are laughing or cursing at me right now. But, okay, so something's going on here. I'm all completely open. That's there. That's open. That's open. Very interesting. Got lots of pressure. I'm wide open. I can flow it. If I flow it, let's see. So I think what we're going to try here is we're just going to see if we can go direct. Close this off. I won't be able to read the pressure, but at least I'll be able to tell if argon is flowing into the system. Yeah, let's do it this way. So I have control. Okay, no air. Isn't that interesting? Okay, well, we're going to try taking the Schrader valve out of one side. Of course, that means we're going to take the charge out of the system. I shouldn't say charge, the pressure. Refrigerant's still locked up in the mini split. So this is what makes me think it's not the Schrader valve, because it cut off the flow as soon as I did that. But let's take it out just in case. So this is a very unusual placement for the service valves. You wouldn't be able to actually put a core removal tool on it, which is unusual. Okay, so let's try that again. I doubt this is going to make a difference, so I'm going to be stuck after this and reaching out for help, I think. Okay, so valves are open. These are all closed. Open this up. Oh, that's already open. Okay, so now we're going to, let's close those and let's remember to bleed those out. Okay, and okay. Let's see what we got now. So we're going up and we're flowing fairly high. I'm going to, just for now, I'm going to flow through the system, make sure it's well purged. Okay, now we're charging or pressurizing. Get it nice and tight. Okay, I'm at a loss. I'm at a complete loss. It's even less pressure than it was yesterday. Oh, I wish you internet people could reach out and tell me what to do here. I don't see anything obvious. I'm basically at 50 psi. Okay, this has been a frustrating and expensive day for me. So the reason I couldn't get above 100 psi wasn't that I was out of gas on the big tank. In fact, I had lots of gas left on the big tank, and so I didn't need to spend $80 renting this other tank today. The problem was that the regulators were set to a maximum. They wouldn't go above 100 psi, and there's nothing in the literature to basically say that. So that was an interesting realization. I guess because these are meant for TIG welding, that's the maximum pressure that you'd ever need. So what I ended up doing was bastardizing one of my regulators. I put some washers in it to depress the diaphragm further so that I could get a higher pressure out of it. The downside to that is that it was leaking like a sieve. So I was putting probably more argon into the atmosphere than I was through my lines. So I was able to get the system up to 200 and did a bubble test everywhere and no problems. But on the computer, I was able to see that the indoor module pressure transducer reading was slowly going down. And I knew it was going to go down a little bit as it equalized between the sides, but it just kept on going down, and it was too much for me to feel comfortable. So I had already put the cover back on. I had left basically two hoses with the shutoff valves here connected, and I could hear a very slow hiss on the very last connection of one of the hoses. And no matter what I did, no matter how I tightened it, it would not stop. So obviously it was a problem with the seal. And of course, it was this one, and this was the one that I had taken the Schrader valve out of just to make sure I had proper flow through the system when I was having problems getting it above 100. So that, of course, meant that I had to depressurize the system, put the Schrader valve back in, and then when I went to recharge the system, I didn't have enough gas left. I had gone through the rental cylinder as well as the 110 cubic foot cylinder, and both of them were to the point where I could only get 175 psi in here. So I've charged it to 175 psi. I've taken off all the hoses, sealed all of this up. If in the morning we're still at 175 or 174, that's going to be good enough, and I will then start to do a vacuum on the system. Expensive lesson learned, inexperience. Regulators don't always give you the maximum output that the specs say. So for instance, on the one that had the flow meter on it, the specs just said it was good for 4,000 PSI. And it doesn't talk about the outflow maximum pressure whatsoever. But apparently it wasn't above 100 PSI. Anyway, so that's it. I'll bring you back when we're doing the depressurization, the vacuum, and letting go the refrigerant load from the heat pump. That should all be tomorrow. Thanks for coming.